hence equals to 20 sigma pi r square. Now if q1 dash and q2 dash be the charge after sharing, then from formula we get q1 dash equals to c1 by c1 plus c2 into q equals to 4 pi epsilon naught r1 divided by 4 pi epsilon naught r1 plus 4 pi epsilon naught r2 into q, or q1 dash equals to r1 by r1 plus r2 into q equals to r by r plus 2r into q r by 3r into q equals to q by 3. Hence q1 dash equals to 20 sigma pi r square by 3. Similarly, we get sigma 1 and sigma 1 dash equals to q1 dash by 4 pi r1 square equals to 20 sigma pi r square by 3 into 4 pi r square equals to 5 by 3 sigma. So the surface charge density after sharing will be 5 by 3 sigma. Similarly, q2 dash r2 by r1 plus r2 into q equals to 2r by r plus 2r into q equals to 2r by 3r into q, or q2 dash equals to 2 by 3q equals to 2 by 3 into 20 sigma pi r square. Hence sigma 2 dash equals to q2 dash water divided by 4 pi r2 square equals to 2 by 3 into 20 sigma pi r square by 4 pi 2r square equals to 2 by 3 20 sigma pi r square by 4 pi into 4r square equals to 5 by 6 sigma. Hence after sharing, the surface charge density of second sphere will be 5 by 6 sigma. Two conducting sphere of radius 6 cm and 12 cm each having same charge of rho into 10 to the power minus 8 coulomb are kept very far apart. If the spheres are connected to each other by a conducting wire, find A, the direction and amount of charge transferred, B, final potential of each sphere. Solution: as V equals to 1 by 4 pi epsilon naught q by r for a spherical conductor, that is V proportional to q by r. Hence V proportional to 1 by r because q is same for both spheres. So a smaller sphere has greater potential and hence charge will flow from a smaller sphere to bigger sphere. As we know that charge flow from bigger potential to a smaller potential. Before sharing, total charge equals to q equals to q1 plus q2. This implies q equals to 3 into 10 to the power minus 8 plus 3 into 10 to the power minus 8, 6 into 10 to the power minus 8 coulomb. Now after sharing, we have q1 dash equals to r1 by r1 plus r2 into q equals to 6 cm by 6 cm plus 12 cm into 6 into 10 to the power minus 8 equals to 6 by 18 into 6 into 10 to the power minus 8 coulomb equals to 2 into 10 to the power minus 6 coulomb. Hence q2 dash equals to r2 by r1 plus r2 into q, 12 cm by 6 cm plus 12 cm into 6 into 10 to the power minus 8 coulomb equals to 4 into 10 to the power minus 8 coulomb answer. So charge transferred equals to q minus q1 dash equals to q2 dash minus q2 equals to 1 into 10 to the power minus 8 coulomb. B. After sharing, the potential of each sphere v1 dash equals to q1 dash by c1 equals to q1 dash by 4 pi epsilon naught r1. Putting value we get 3 kilovolt. Similarly, v2 dash q2 dash by c2 equals to q2 dash by 4 pi epsilon naught r2. Using respective value we get 3 kilovolt. That is, after sharing, both conductors are at same potential which is required. Question: two conducting a sphere of radius 4 cm and 7 cm have charge of 500 coulomb and 60 coulomb respectively. Calculate the loss or gain of energy when they are connected together. Solution. As electrical energy stored in a conductor is given by U equals to 1 by 2 QV equals to 1 by 2 CV square equals to Q square by 2C. Here, as conductors are spherical, hence C equals to 4 pi epsilon naught R. So Ui equals to 1 by 2 under bracket Q1 square by C1 plus Q2 square by C2 equals to 1 by 2 under bracket Q1 square by 4 pi epsilon naught R1 plus Q2 square by 4 pi epsilon naught R2. Now putting all values and solving, finally we get equals to 2.835 into 10 to the power 16 joule. Now when the two conductors are connected together, C equals to C1 plus C2, 4 pi epsilon naught under bracket R1 plus R2. Hence C equals to 1 by 9 into 10 to the power 9 into 11 into 10 to the power minus 2 farad. Answer. So UF equals to Q square by 2C. Using all value we get UF equals to 1.283 into 10 to the power 16 joule. And as UF is less than UI, there is a loss of energy and is given by delta U equals to UI minus UF, which comes out to be 1.551 into 10 to the power 16 joule. Answer.